1 dimension, yeah. Yeah, 2 dimensions you won't be embracing. That's when the crying starts. So we're dealing with 1 dimension. I don't mean to freak you out. Okay, so motion. Let me ask you this question. Sit real still, except for your breathing. You can grip the edge of your desk if you need to. Are you moving?
Yes.
How many of you would say yes? How many of you would say no?
Yes.
Yes. She's going to say the answer. No.
We are moving.
No, I'm going to say it depends. You can't answer that question without more information. That's what I'm going to say. What do you mean you're moving? You can answer it, but it's not a very precise answer. Okay, what do you mean you're moving? Your atoms are always moving. Okay, you are affixed to this giant ball of rock that is hurtling through space at, gazillions of meters per second. So you're moving pretty fast, but that's with reference to the sun or to other planets. With reference to the surface of the earth, sitting in that desk, are you moving? No. So motion is always about frame of reference. We can only talk about motion if we talk about a frame of reference. We perceive motion in 3 dimensions. And they are, and there's a dance to go with them. You knew there was. Everybody stand up.
Like YMCA.
No. Okay, so those are the 3 dimensions that we perceive motion in. There's a 4th dimension that we commonly perceive, but we don't talk about motion in that 4th dimension. What is it? Do you know? Time. Time is the 4th dimension. So we are 3-dimensional creatures living in a 3-dimensional world, but time is typically described as the 4th dimension. String theory posits that there are 11 dimensions. Don't think about that too hard. Your head will hurt. I can't even begin to think about it. So we describe these based on the Cartesian coordinate system. Those are those axes we talk about, X, Y, Z. The Z-axis, coming at ya. Get it? The Z-axis, coming at ya. The Z-axis is out towards you. So the X, the Y, the Z. Okay. For the purposes of this chapter, we are going to deal with 1 axis at a time, and we will start off with the x-axis. Okay? And that's a good thing. Yeah. Okay, so when we talk about 1-dimensional motion, this is something that can only move back and forth, back and forth, back and forth. And the common sort of visualization for this is a railroad car on a track. And this is a track that doesn't curve. This is a straight shot track. You can only go back and forth, back and forth, back and forth. We calculate, typically, in this scenario, displacement. And displacement is the difference between your initial and your final position. Okay? Displacement is just your initial position, or your final position minus your initial position. It is this distance. Well, no, I should be careful. It is this difference. I have to be very careful. It's that difference in the initial and final. So we talk typically, when we're doing these, about x1, x2, or x initial, x final. We use a lot of little subscripts in physics. Of course, when we subtract them, what we get is delta x. And that's the first place where we're going to use delta a lot, is in change in position. So that's read as change in position. And this is all change in position on the x-axis, so it's all delta x. At the end of this chapter, we will start talking about delta y. In the next chapter, we start talking about delta x and y simultaneously. Right now, we deal with one at a time. Okay, so the distance that you travel is very often different from your displacement. No. Okay, so this gets back to our example this morning about you getting up out of bed and going over half of Columbiana County, including chasing a goat, leaving Columbiana County, going into West Virginia, all this stuff. But if the place you started out is the place you end up, then you've really gone nowhere. So if you start out at your little bed Okay, so if you start off on your little bed in the morning, doesn't matter how far you go. If you end up back there that night, your overall displacement for the day is zip. Nothing. You've gone nowhere. Your delta... Isn't that sad? It's okay, really, though, because you know what? You can do a lot within the context of having gone nowhere. Yeah. If you start off and end up in the same place, your displacement is 0. That is different, and this is the part that will make you undepressed. Your distance is different. You may have gone a great distance. You may have traveled, miles, hundreds of miles, whatever. If you end up back where you started, your overall displacement is 0. And that's what we talk about in physics is displacement. Distance is absolute. So distance is not positive or negative. It's just a magnitude. So if you got up from bed and you did this whole circuit through half of Columbiana County, part of West Virginia, went to Pittsburgh, etc., and got home, the number of miles you clock is what's going to be on your odometer. Or if you've got a little pedometer that you've set in meters because you're a budding physics student and you want to get a conception of what the metric system feels like in real life, the number of meters that you have walked, that's the distance you've traveled. Nobody can take those meters away from you. So, see, they're not for nothing. But your displacement can be positive or negative. So let's think back to our train example. So our displacement can be positive or negative because displacement is heavily dependent on a frame of reference. So let's say we call this start. Okay? And here's our little person. Terrible, 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 terrible. There. Only slightly better. So if this is our start point, then if they travel this way, by convention, we call this positive. And all you have to do is think about the Cartesian coordinate system, where start is your origin. So by convention, we call travel in that direction positive, and travel in this direction negative. So what if they go here, and then they go a little bit further this way, and then they come back here? Their overall displacement is going to be negative. Because for displacement, we're only looking at the difference between this point and this point. So that would be x initial, and this would be x final. Okay? So we only care about the difference between those 2 points, and therefore it can be negative. It's all based on reference to the start point.